Hello. So, this video is a quick overview of revision 18, the Flatlight revision 18, and I start with the LED side. On the top there are 8 J series Cree LEDs. One has a NTC next to it, which is thermally coupled to one pad of the LED. They are driven by this MOSFET. It's an N-channel MOSFET. Wait, I could need a scene. Late side. Schematics. So it's in DMN 2022 UFDF7 in an UDF8 package, I believe. It has a 1.2 meg pull down and a 1K pre for the gate, which goes to the microcontroller, and that's the 1% 10K resistor for the divider network together with the NTC. Same's on the bottom row, except here are X lamps, and the NTC is coupled to the thermal pad of the X lamp. These only have 2 pads, these have an extra thermal pad. The current or main current transportation is over the mounting holes. In the center 2 is VCC, and the 4 corners carry ground. On the bottom side is nothing much except the board connector for the signals and a nice QR tag, which is silvery. Well, on the main board there are no components anymore on the top layer except these 2 resistors. So if you conformally code that, it's nice and protected. It's almost waterproof, well, this surface, and you can't mechanically damage any components. All the magic is on the bottom layer, and it goes like this. Here's the battery is a 3000 milliamp hour LiPo. It's a BG930 ABE. It's the same LiPo which is used in a Galaxy S7, which have these flex connectors, and this is the B2B mezzanine connector for the LiPo. Hi Tiger. Yeah, you get your food soon. Give me a second. That's an wait, I can show that too. Meow meow. MCP 73831. I always forget that number. It's an MCP LiPo charge controller. Is the circuitry for the charge controller. It's an RGB LED. It's not a pixel. It's just 3 LEDs in one package for charge indication, a little bit smoothing, a little bit more smoothing. It's a micro USB for charging. It has no connection. The D plus and minus lines are not connected. That's the push button for the soft latch. The soft latch PN MOSFET is quite a bit overkill, but it was actually cheaper than an appropriate sized device. So it's a DMC 1016 UPD dual MOSFET with a P and an N MOSFET in there. Timing circuitry, and here's the IMU. That's an LSM6DS3. A little bit smoothing, pull-ups for SCL and SDA. Here's one Tiga. Here's an 2 pixels. These are APA 102 2020 packages. Pull-ups for the digital buttons, some more smoothing, and that LC network is for measuring the battery voltage. Also, it provides relatively stable voltage for measuring the NTCs, so the analog lines. Nicht dahin. This is the programming header for the programming header for the MCU, and here's the board connector which goes to the LED side with the NTC and PWM signals. That all is held together with a 3D printed frame. I fitted a little felt pad which goes on top of the flex connector for the LiPo and hold it nice in place. When this is together and screwed down, that will not come loose. I made sure of that. And the whole stack is like this. I have buttons printed out too. It's like this, and it's like 9 millimeters high. Yeah. So with conformal coating, maybe 10 millimeters with the LEDs and stuff. So that fits nicely into your pocket and delivers 10 watts of LED power, peak power, I think. And so that's 2.5, 3 amps from the LiPo drawn. That's 1C. That's what I had in mind. So maybe you can draw more, but I don't know the cutout voltage of the protection MOSFET from the LiPo. I never went that far. Also, you can't go that high. I mean, theoretically, these are 350 milliamp each. So that's like 1 watt LEDs and times 8 plus these are 2 watts or 3 watts times 4. The theoretical value is very much higher, but you don't want to have them at full power because of the heat. The NTCs make sure that the board stays below 45 degrees C, so that the LiPo will not be cooked. Du kriegst gleich HP. Yeah, you can have a head strap in here and fit it to your head, and the control is by tapping, or in manual mode you have these push buttons to go bright and dark. At full power, this light will last for like 1 or 2 hours, 1.5. And at Firefly mode, so like with a 1% duty cycle, all night long, like you can finish your book in the tent or something. Yeah. So I hope you liked that video or found it interesting. If you want one, you can build one yourself. It's open source hardware or licensed under the Creative Commons, so you can go to GitHub and make your own, right? Or if you want to have a special design with your logo on it, you can contact me over GitHub and I will make one for you. So have a nice day. Bye bye.